full view of the James Webb Space Telescope's near-infrared camera instrument. An estimated 500,000 stars shine in this image of the Sagittarius C region, along with some as yet unidentified features. A vast region of ionized hydrogen, shown in cyan, wraps around an infrared dark cloud, which is so dense that it blocks the light from distant stars behind it. Intriguing needle-like structures in the ionized hydrogen emission lack any uniform orientation. Researchers note the surprising extent of the ionized region, covering about 25 light-years. A cluster of protostars, stars that are still forming and gaining mass, are producing outflows that glow like a bonfire at the base of the large infrared dark cloud, indicating that they are emerging from the cloud's protective cocoon and will soon join the ranks of the more mature stars around them. Smaller infrared dark clouds dot the scene, appearing like holes in the starfield. Researchers say they have only begun to dig into the wealth of unprecedented high-resolution data that Webb has provided on this region, and many features bear detailed study. This includes the rose-colored clouds on the right side of the image, which have never been seen in such detail. The James Webb Space Telescope has observed the very outskirts of our Milky Way galaxy. Known as the extreme outer galaxy, this region is located more than 58,000 light-years from the galactic center. To learn more about how a local environment affects the star formation process within it, a team of scientists directed the telescope's near-infrared camera and mid-infrared instrument towards a total of 4 star-forming areas within Diggle Clouds 1 and 2, 1am, 1b, 2n, and 2s. In the case of Cloud 2s, shown here, Webb revealed a luminous main cluster that contains newly formed stars. Several of these young stars are emitting extended jets of material from their poles. To the main cluster's top right is a subcluster of stars, a feature that scientists previously suspected to exist but has now been confirmed with Webb. Additionally, the telescope revealed a deep sea of background galaxies and red nebulous structures that are being carved away by winds and radiation from nearby stars. L1527, shown in this image from the James Webb Space Telescope's mid-infrared instrument, is a molecular cloud that harbors a protostar. It resides in the constellation Taurus, about 460 light-years from Earth. The more diffuse blue light and the filamentary structures in the image come from organic compounds known as polycyclic aromatic hydrocarbons, while the red at the center of this image is an energized, thick layer of gases and dust that surrounds the protostar. The region in between, which shows up in white, is a mixture of polycyclic aromatic hydrocarbons, ionized gas, and other molecules. As the protostar continues to age and release energetic jets, it'll consume, destroy, and push away much of this molecular cloud, and many of the structures we see here will begin to fade. Eventually, once it finishes gathering mass, this impressive display will end, and the star itself will become more apparent, even to our visible light telescopes. This image includes filters representing 7.7 microns light is blue, 12.8 microns light is green, and 18 microns light is red. This stunning new mosaic of images from James Webb Space Telescope showcases the nearby star-forming cluster, NGC 1333. The nebula is in the Perseus molecular cloud, and located approximately 960 light-years away. The center of the image presents a deep peek into the heart of the NGC 1333 cloud. Across the image we see large patches of orange, which represent gas glowing in the infrared. These so-called Herbig-Haro objects form when ionized material ejected from young stars collides with the surrounding cloud. They are hallmarks of a very active site of star formation. Many of the young stars in this image are surrounded by disks of gas and dust, which may eventually produce planetary systems. On the right-hand side of the image, we can glimpse the shadow of one of these disks oriented edge onto 2 dark cones emanating from opposite sides, seen against a bright background. Similarly to the young stars in this mosaic, our own sun and planets formed inside a dusty molecular cloud, 4.6 billion years ago. Our sun didn't form in isolation but as part of a cluster, which was perhaps even more massive than NGC 1333. The cluster in the mosaic, only 1 to 3 million years old, presents us with an opportunity to study stars like our sun, as well as brown dwarfs and free-floating planets, in their nascent stages. In this image of the Serpens Nebula from the near-infrared camera on the James Webb Space Telescope, astronomers found a grouping of aligned protostellar outflows within one small region, the top left corner. In the Webb image, these jets are identified by bright red clumpy streaks, which are shockwaves caused when the jet hits the surrounding gas and dust. The Serpens Nebula, located 1,300 light-years from Earth, is home to a particularly dense cluster of newly forming stars, around 100,000 years old, some of which will eventually grow to the mass of our Sun. This region has been home to other coincidental discoveries, including the Flapping Bat Shadow, which earned its name when 2020 data from the NASA/ESA Hubble Space Telescope revealed it to flap, or shift. This feature is visible at the center of the Webb image. To the right of the bat shadow lies another intriguing feature, an eye-shaped crevice, which appears as if a star is bursting through. However, astronomers say looks may be deceiving here. This could just be where gases of different densities are layered on top of one another, similar to what is seen in the famous pillars of creation. And to the right of that, an extremely dark patch could be a similar occurrence. The gas and dust here are so dense in comparison to the rest of the region that no near-infrared light is getting through. This image of Uranus from near-infrared camera on the James Webb Space Telescope shows the planet and its rings in new clarity. The Webb image exquisitely captures Uranus's seasonal north polar cap, including the bright, white, inner cap and the dark lane in the bottom of the polar cap. Uranus' dim inner and outer rings are also visible in this image, including the elusive Zeta ring, the extremely faint and diffuse ring closest to the planet. This Webb image also shows 9 of the planet's 27 moons. They are the blue dots that surround the planet's rings. Clockwise starting at 2 o'clock, they are Rosalind, Puck, Belinda, Desdemona, Cressida, Bianca, Portia, Juliet, and Perdita. The orbits of these moons share the 98-degree tilt of their parent planet relative to the plane of the solar system. One day on Uranus is about 17 hours, so the planet's rotation is relatively quick. This makes it supremely difficult for observatories with a sharp eye like Webb to capture one simple image of the entire planet, storms and other atmospheric features, and the planet's moons move visibly within minutes. This image combines several longer and shorter exposures of this dynamic system to correct for those slight changes throughout the observing time. Near the outskirts of the Small Magellanic Cloud, a satellite galaxy roughly 200,000 light-years from Earth, lies the young star cluster NGC 602, which is featured in this new image from the James Webb Space Telescope. This image includes data from Webb's near-infrared camera and mid-infrared instrument. The local environment of this cluster is a close analog of what existed in the early universe, with very low abundances of elements heavier than hydrogen and helium. The existence of dark clouds of dense dust and the fact that the cluster is rich in ionized gas also suggest the presence of ongoing star formation processes. This cluster provides a valuable opportunity to examine star formation scenarios under dramatically different conditions from those in the solar neighborhood. An international team of astronomers, including Peter Zeidler, Elena Sabbi, and Antonella Nota, used Webb to observe NGC 602 and detected candidates for the first young brown dwarfs outside our Milky Way. In this mosaic image stretching 340 light-years across, Webb's near-infrared camera displays the Tarantula Nebula star-forming region in a new light, including tens of thousands of never-before-seen young stars that were previously shrouded in cosmic dust. The most active region appears to sparkle with massive young stars, appearing pale blue. Scattered among them are still embedded stars, appearing red, yet to emerge from the dusty cocoon of the nebula. To the upper left of the cluster of young stars, and the top of the nebula's cavity, an older star prominently displays NIRCM's distinctive 8 diffraction spikes, an artifact of the telescope structure. Following the top central spike of this star upward, it almost points to a distinctive bubble in the cloud. Young stars still surrounded by dusty material are blowing this bubble, beginning to carve out their own cavity. Farther from the core region of hot young stars, cooler gas takes on a rust color, telling astronomers that the nebula is rich with complex hydrocarbons. This dense gas is the material that will form future stars. On June 25, 2023, James Webb turned to famed ringed world Saturn for its first near-infrared observations of the planet. The initial imagery from Webb's near-infrared camera is already fascinating researchers. Saturn itself appears extremely dark at this infrared wavelength observed by the telescope, as methane gas absorbs almost all of the sunlight falling on the atmosphere. However, the icy rings stay relatively bright, leading to the unusual appearance of Saturn in the Webb image. This new image of Saturn clearly shows details within the planet's ring system, along with several of the planet's moons, Dione, Enceladus, and Tethys. Additional deeper exposures, not shown here, will allow the team to probe some of the planet's fainter rings, not visible in this image, including the thin G ring and the diffuse E ring. Saturn's rings are made up of an array of rocky and icy fragments. The particles range in size from smaller than a grain of sand to a few as large as mountains on Earth. Researchers recently used Webb to explore Enceladus, and found a large plume jetting from the southern pole of the moon that contains both particles and plentiful amounts of water vapor. This plume feeds Saturn's E ring. Saturn's atmosphere also shows surprising and unexpected detail. This is the first time that the planet's atmosphere has been seen with such clarity at this particular wavelength, 3.23 microns. The large, dark, diffuse structures in the northern hemisphere do not follow the planet's lines of latitude, so this image is lacking the familiar striped appearance that is typically seen from Saturn's deeper atmospheric layers. The patchiness is reminiscent of large-scale planetary waves in the stratospheric aerosols high above the main clouds, potentially similar to those seen in early Webb NIRCam observations of Jupiter. This image features the central region of the chameleon eye dark molecular cloud, which resides 630 light-years away. The cold, wispy cloud material, blue, center, is illuminated in the infrared by the glow of the young, outflowing protostar SED 110 IRS4, orange, upper left. The light from numerous background stars, seen as orange dots behind the cloud, can be used to detect ices in the cloud, which absorb the starlight passing through them. An international team of astronomers has reported the discovery of diverse ices in the darkest, coldest regions of a molecular cloud measured to date by studying this region. This result allows astronomers to examine the simple icy molecules that will be incorporated into future exoplanets, while opening a new window on the origin of more complex molecules that are the first step in the creation of the building blocks of life. Thanks for watching. If there's real interest, I'll make the files available. Space speaks to those who listen.